All right, I'm going to walk you through the steps on how to do a differential level survey. So what we have right here is a sheet we'll call our field notes. It contains on the right hand part some grid paper to create a sketch, and on the left hand side is where you will put in and calculate all your information. All right, and so I have 4 points on my sheet right here. It doesn't necessarily matter that they are exactly placed on yours like it is mine. We are going to use this diagram to complete our survey. And so I'm going to label this point right here in the corner BM for benchmark. I'm going to label this point A. This will be point B. And this down here will be point C. And so what we are going to do is we're going to create a survey or do an example survey of just a rectangular. This is called a circuit survey because it is closed loop. And so being that it's closed, it's called a circuit survey. So I'm just going to go ahead and draw some lines to show that this is a closed circuit survey. All right, the next step will be to go ahead and figure out what the elevation of the benchmark is. And so if you have a benchmark, an actual benchmark that we know, you could put in that information. You could also get a GPS unit and get the actual elevation of that location. But it's common practice, if you don't know that elevation location, to use 100 as that information. And so over here under point, I'm going to put BM for benchmark, and I'm going to go ahead and establish, we're just going to guess that elevation, or we're going to use the constant of 100 feet. All right, and so under elevation in the table over here, I'm going to type in or write in 100. Okay, the next step will be to we would take the instrument to point A, and we would shoot back a back sight of the benchmark. And so I'm going to go ahead and write on here, this is going to be the back sight for the benchmark location. All right, and we are going to shoot that back this way. And so the rod is going to be placed at the benchmark. We're going to move the instrument to point A. We'll flag both locations, and then we will get a reading. And so when we look through our auto level, the reading is going to be 12.64 in this case. So I'm going to go ahead and write that in right here. And I'm going to go ahead and write that as my back sight to the benchmark. 12.64. So what we can do now is we can go ahead and write in the top and bottom stadia points so we can figure a distance. And so again, when I'm looking through my auto level back at the benchmark, the top was going to be 13.61 and the bottom is going to be 12.48. So this is the data you'd be collecting if you were out doing your survey. The other thing that we can calculate is the height of the instrument. So the height of the instrument is the back sight plus the elevation. And so this one is going to be 112.64. Okay. The next step that we will need to do is move the rod from the benchmark to location B. Then we would put a flag at location B, and we would take our foresight of from point A. And so this is going to be the foresight to point A. And I'll go ahead and draw my arrow this way. So we're going to, again, the rod's now at point B. We're going to create a foresight. from point A. I'll go ahead and put point A here. Look at through my auto level, we get a measurement of 3.11 feet. We have a top stadia of 11.01, a bottom of 10.72. So I'll record those, and then I can figure the height of the instrument and the elevation of that information. So my elevation this time is going to be the height of the instrument, which we know, minus the foresight. And so foresights are always subtracted, backsights are always added. And so I'm going to take 112.64 minus 3.11, and I get 109.53. All right. And so then I can move my instrument to point B, move my rod to point A, and I can get a back sight to point A. So this is going to be the back sight to point A. And move it this way. So we're going to shoot back to point A, and this time our reading is 10.88 feet, which allows us to calculate the height of the instrument. So we'll take that elevation of 109.53, which is right here, and we will add it to 10.88, and we get 120.41 for our height of the instrument at point A. So then the next step would be to be able to shoot a foresight to point B. And so we move the instrument back to point B. We will go and we will shoot the foresight from B. So that's going this way. So the rod will be at point C, our instrument at point B. We record our foresight reading, it's 2.56. We will be able to calculate the elevation of that, and so we will subtract 120.41, which is the height of the instrument, minus the 2.56, and we get 117.85 for the elevation. And so that's the elevation of the point. And so then we would rearrange. We would move the instrument to point C. We would move the rod to point B, and we would shoot our back sight to point B. And so when we do that, we get a reading to the back sight of B at 9.72, which will allow us to calculate the height of the instrument at point B. And so we'll do that by taking the 124, or excuse me, we'll do that by taking the elevation at point B plus the back sight. And so 117.85 plus 9.72 gives us 127.57 feet. We forgot to record our bottom and top stadia for point B, and so we'll go ahead and do that. 10.61 and 9.59. The next step will be to shoot a foresight to point C, and so our rod is, or our instrument's going to be at point C. Our rod is going to be back at our benchmark, which will close our loop for us. And so the foresight for C is what we're shooting now. And so I'll go ahead and put point C here. We get a reading for the foresight of 3.10. that will allow us to calculate the elevation. But the first thing we'll do is we'll write in the top and bottom stadia lines 3.20 and 2.90. And so to calculate that elevation now, we take our height of the instrument at point, and then we subtract it from the foresight. And so 127.57 minus 3.1 gives us 124.47. And so that is the elevation. And so the next thing that you can do is you can go ahead and start calculating these distances. And so when we were done, we would go ahead and finish our sketch over here. And we would do that by taking the top stadia, 13.61 for this one, minus the bottom, 12.48. And then we multiply that number by 100. And we get how many feet are between those 2 points. And so this is 113 feet between points benchmark and A. And so I'll go ahead and write that on my table. Do the same thing for between point A and B, 11.01 minus 10.72 times 100. And I get 29 feet. 10.61 for B and C now. Minus 9.59 times 100, 102 feet. So this one was 29 feet. This one's 102 feet. And then our last one, 3.2 minus 2.9 times 100, 30 feet. So here we have a distance of 30 feet. And so the last thing that I would want you to do, actually we have two more things to do. Go ahead and write in the reading for the foresights and backsights. And so the foresight at A is 3.11. The backsight to A was 10.88. The foresight to B was 2.56. The backsight to B was 9.72. The foresight to back to the benchmark, or C, was 3.10. So that would be considered a finished graph. The last thing that you'll do is go ahead and take this. You can fold it in half, secure it in your engineering notebook as your differential leveling example, and you should be able to glue the backside in and then unfold it so you can see all your data and use it as an example when you go do your own controlled survey.